Hello, my name is Seth Robbins, and this is a research presentation on the influence of fatigue on the flexors and extensors of the wrist. Many activities of daily living require sustained isometric contractions. These include activities involving carrying an object for an extended period of time or pushing an object for an extended period of time. Recognizing the physiological implications of these actions and the body's reaction to these contractions involving consistent force production can help physical therapists to identify when and why injuries are likely to manifest themselves. Previous research has identified that as a muscle attempts to maintain a maximal voluntary isometric contraction, more motor units will be recruited to maintain that consistent maximal force, and therefore electrical activity at the muscle will increase. This increase in electrical activity has been witnessed using electromyography, where an increase in amplitude of electrical signals sent to the muscle is seen. This study sought to determine the influence of fatigue on muscle force and EMG amplitude over time during an isometric contraction at only 25% of the peak grip force capable of a healthy adult participant. It was hypothesized that as the muscle fatigued over time, muscle force would remain relatively consistent as EMG amplitude increased as the muscle attempted to recruit more motor units. 5 male and 3 female participants were recruited from the Regis University Doctor of Physical Therapy program and were required to be healthy and have no upper extremity injuries. Electrodes were placed on shaved and alcohol-wiped areas of the skin over the extensors and flexors of the wrist. They were then asked to contract against resistance from the researcher's hand, and electrode placement was confirmed with corresponding EMG activity on the recording device. The participant was then asked to perform a maximal voluntary contraction on a hand grip dynamometer appropriately adjusted to match the size of the participant's hand. Grip force and peak EMG data were recorded for both the wrist flexors and extensors during this maximal contraction. The participant was then asked to maintain 25% of this maximal grip force for as long as they were capable. A timer was started at the beginning of the task, and peak EMG and force were measured every 15 seconds until the participant could no longer maintain the contraction or the time reached 300 seconds. Means and standard deviations were calculated for force and EMG amplitude of the wrist extensors and flexors. Percent standard relationships were calculated to determine the percent of EMG amplitude and force that was seen in the submaximal grip activity in comparison to the maximal grip. Mean wrist extensor and flexor EMG amplitudes trended towards a positive increase up until around 195 seconds, at which time some of the participants began to reach fatigue and no longer contributed to the mean. Overall, mean muscle force remained consistent at 42.1 kilograms with a standard deviation of only 12.26. EMG amplitude over time is described in the graph on the left, while the percent of EMG amplitude over time in relation to maximal grip force over time is described in the graph on the right. In both graphs, wrist extensors are represented by the blue line and wrist flexors are represented by the orange line. These results support the hypothesis in both the noted trend towards an increase in EMG amplitude in the muscles over time, as well as the consistent force exhibited by the muscles during the activity until the point of fatigue. Sustained submaximal isometric contractions put a substantial toll on the working muscle, as an increasing number of neural impulses are sent to the muscle in motor recruitment before the muscle eventually fatigues. In a study by Keller et al., a group of college-age women were asked to sustain a submaximal isometric leg extension, but instead of maintaining a constant force, they were asked to maintain a constant rate of perceived exertion of 5. EMG monitoring showed that force decreased over time as they maintained their rate of perceived exertion, but EMG amplitude did not change significantly, suggesting that there may be a link between perceived exertion and motor unit recruitment. In relation to this previous study and the current study, in activities involving submaximal isometric contraction, it is important to identify the amount of exertion perceived by the individual performing the action to predict how close they are to their point of muscular fatigue when the activity must be stopped. In a study by Lark et al. Involving a 12-minute rotational prone bridge test, it was found that cycling through various positions can allow some recovery of those fatigued muscles. Clinical implications of these findings suggest that training muscles used frequently in sustained isometric contractions can help to protect the body against muscular injury due to fatigue, and that when developing exercise protocols, it is important to cycle between active muscles to avoid muscular fatigue even during submaximal exercise, since the same mechanisms of muscular fatigue are seen. Thank you.